Today we're doing section 2.5. It's all about correlation and best fitting line. We're going to talk a lot today about scatter plots. It's just a way to show data, usually when you're talking about two things, because they're all ordered pairs. And then we're going to approximate the best fitting line for a set of data. Has anyone ever heard of a scatter plot?
Yes.
Yeah, I'm sure you've seen them. They're pretty common, especially when you're talking about statistics. Questions? All right, here are the definitions you need to know today. So the first one is a scatter plot. I already talked about it a little bit, but a scatter plot is a graph used to determine whether there is a relationship between paired data. Paired data means you're comparing two things like height and weight, or time studying and test grade. So there's always two things you're talking about. If they are going up together, if y is increasing with x, it has a positive correlation. If y tends to decrease as x increases, we say it's a negative correlation. And I'll show you pictures of each of those in just a second after you get the definitions down. Any questions? So here are some examples of some scatter plots. We'll look at a couple more with some real life stuff involved. But for now, I just want you to know if it looks like this is a positive correlation. So as the x values are increasing, so are the y's. They're going up together. A negative correlation, the farther you get on the x, the bigger the x's, the smaller the y's. And then no correlation is when there's not really a pattern at all. It's just random data points. Okay, I do want to point one thing out about a scatter plot. I've seen students graph these, and then they go through and they start like doing this. Okay, that is not what this is. You don't connect these lines. Okay, so don't be that student. These are just data points. What are your questions on this? All right, I do want to mention one thing. And if you ever take a statistics class, or they talk about this in a psychology class a lot, this does not prove cause and effect relationship. So, for example, I heard something the other day on the radio that said, people that drink water with lemons in it lose weight faster. Okay, so your weight loss is going to increase as you drink water with lemons in it. So that tried to make it sound like the lemons were causing you to lose weight, right? But maybe healthy people just like the taste of lemons, right? It does not prove that one causes the other. So do not fall for statistics and marketing and commercials that you see where they try to say something causes something else. Sometimes it just happens to be a coincidence. People that drink lemon water are healthier than people that don't. It doesn't mean lemons make you healthy. It might just be a coincidence. Okay, so don't fall for tricks that commercials might show you about correlation. Any questions in general? All right, here are two examples, some real life data that has to do with a positive correlation. So this is the number of hours that you study and your test score. Again, you can't necessarily say that studying improves your grade. Maybe it's just that good students study longer in general. So it's not really a cause and effect relationship. It's just saying that this is the relationship that exists. We can't really make many conclusions. That's just what it is. All right. The other one is years of experience versus your income. That one you probably could prove a cause and effect relationship. But again, don't assume too much from this data. Any questions? Here's some examples with the negative correlation. So this says weight of your car and miles per gallon. So heavier cars are getting less miles per gallon. This one is the driver's age on the x-axis. This is sign legibility. So young drivers can read signs, I guess, up to 600 feet away. The older drivers are not reading the signs as well. So just some examples of a negative correlation. Any question on those? No. Kind of interesting. All right, here is our first example for today. So they give us a bunch of ordered pairs. The directions say to graph the scatter plot and then say if it's a positive correlation, negative correlation, or no correlation. So I am going to start graphing those points. I'm not going to talk too much about graphing points. I know you guys are pretty good at that.
Could the XY chart be written the other way?
Yeah, you could write it up and down too, the XY chart. Where am I at? -2, -4. -2, 0, 0, 0, 0, -3, 1, 3, 2, 1. Yes, you should have this in your notes. All the examples we do on the board should go in your notes. So it does not take too long. If you need graph paper, there's some over there. But the first thing we're going to do is just graph all the ordered pairs. So we have all the ordered pairs on the graph. Like I said, it doesn't take too long. Pretty simple idea. Now you have to say if it's a positive, negative, or no correlation. What do you guys think?
Positive.
It's positive, yes. As the X increases, so does the Y. All right, here is example 2. We are going to graph those points. Again, we're going to try to see if it's a positive, negative, or no correlation. So, -3, 4. Then I have -3, 0. -2, -1. -1, 2. 0, 3. 0, -3, 2, -2, 2, 4, 3, 2, and 5, 0. Okay. No correlation. Perfect. This is a big mess of data. So this does happen sometimes when you're researching. You think there's a pattern that's not really there. So if you graph it and it doesn't really look like there's a trend, just put no correlation. Any questions on this one? So we are going to approximate the best fitting line. The best fitting line is a line that goes through the data. It does not touch every data point. Oh, hold on one second. It just sort of shows the trend. And we say approximate, you'll see why. These aren't really an exact thing. It's just kind of showing the trend line. They're also called a trend line if you ever hear that. So don't get too hung up if your neighbor has a B of 3 and your B is 4, okay? It's not a big deal, and you'll see as we go through these. So what you want to do, you want to draw your scatter plot, first thing. You want to sketch a line that appears to follow most closely the pattern given by the points. So again, it's not going to touch every point. It might not even touch any of the points. It just needs to go through the data. You want about as many points above the data as there are below the data. So again, it should be right through the middle of your data. We're going to choose 2 points on that line and estimate their coordinates. Again, might not be actual data points. There might not be any actual data points on the line. And then we're going to write the equation just like we did yesterday using those 2 points. So any questions? This will make more sense when you see it, but these are the steps you want to follow. Again, these steps are written in your book, so if you don't feel like writing them down but you get stuck tonight, just open your book and you should see a table with these 4 steps. All right, here is example 3 for today. So we are going to draw the best fit line. Again, this is not a data line that connects all the points of data. This is just a line that goes through the data that will show the trend. So you can use this line to make guesses about future data points or see maybe previous data points that weren't collected, maybe where they might have fallen. So this is just kind of a way to help analyze the data. It's kind of convenient when you get into statistics. So how you want to do this? You want to draw a line that basically cuts the data in half. All right, someone in my last hour was like, oh, well, this cuts it in half. It should follow the trend of the data. It shouldn't just be cutting it in half. So the trend here, oh, I have too many above. So it might take a little bit to draw these. But again, we're just kind of estimating where the middle is. If it's not exactly perfect, it's not a big deal. So this one I have 2 points above, 3 points below, and then a couple points that fall right on the line or very close to the line. That's fine. It does not have to be exact. This is just an approximation. But just draw a line that basically cuts the data in half. Doesn't have to be perfect by any means. Now, the next thing you want to do is pick 2 points on this graph. So it looks like there's a point right there at 4, 0. That's good. And then it looks like right here at 3, 2, there's another point. So again, one of those is a data point. 4, 0 was a data point. 3, 2 was not. It does not have to be exact points from the data, just points that fall along the line that you think fits best with the data. Does that make sense? Yes. Okay, sorry. It's kind of a tricky concept, but hopefully not too challenging. Now, I have 2 points. I want to write an equation that goes through these 2 points. So what am I going to do? Find the slope. Then we'll find b. Then we can write our equation. So I have 0 minus 2, 4 minus 3. So I'm coming up with the slope is -2. All right, how am I going to find b? Yeah, use an x and x and y. It doesn't really matter which one we use. We can do 4, 0. So 0 equals -2 times 4 plus b. All I did was plug in this x and y into y equals mx plus b. Now I'm going to solve for b. Once I find b, I can write my equation. So 0 equals -8 plus b. Add 8 to both sides. I'm getting b equals 8. That's okay. Let me look. You got b equals 7. You used the other one?
Oh, I put the 3 and the 2 in the wrong side.
Oh, yeah. You should, if you pick the same 2 data points as me, you should be getting the same 2 lines. The variation in the answers would be if you drew the line in a different spot or if you picked different data points. But if you're following along, you should still be getting b equals 8. All right, real quick, I'm going to write my equation. So y equals -2x plus 8. Other appropriate answers may be -2.1 plus 7.9. I mean, you can get right around the same answer, and they're all still acceptable. It just kind of depends how accurate your graph was and exactly where you put your trend line. There are computer programs that find the trend line that are a lot more exact than ours, but again, we are just approximating here. All right, here is example 4. There is one thing that I want to draw to your attention before we start going through this. Let's focus on this first point real quick, because this is going to help us with something. The first data point they graphed was 228. So what are they counting by along what they're calling the t-axis? What are they counting by? 2. So I'm just going to make a little note to myself that this is by 2s. Now, they're saying they went up 28, and they're almost to what I would usually call 3. So what are they counting by along the h-axis? By 10s. Good. So be careful on that. If the data points are already graphed for you, that's wonderful, but just double check how they graphed them, because they don't always count by 1s. And they don't always count by the same thing. This way they're counting by 2s, this way they're counting by 10s. So just be aware of that. Okay? Any questions? So the first step is always to graph the data. That was done for us on this one. Now I want to draw in a best fit line. So let me just kind of play around with it. Now this one's kind of tricky because they're almost already a line. Does that look like a good best fit line? I'm okay with that. All right, now let's see if we can pick some data points that are on that line. And I'm going to try to pick one that the t value or the x value is divisible by 2, the h is divisible by 10. What are you guys saying?
640 and
6
1770.
Oh man, 640 sounds like a great one.
And 1770.
Now, 1770 is one of our data points, but is it right on our line? I am not sure. Remember, it doesn't really have to be exactly on the line.
What about the third one from the 640?
I was just trying to.
This one right here?
Yeah.
That looks like a good one. That actually is a data point. If you want to use it, that's fine. We can use it, so that's over 1, 2, 3. So that's, what is that point? 12. Is that 1255? Good. We're actually using 2 data points. That's fine. If 2 data points hit the line, great, use them. They don't have to be 2 data points. There's a couple other points that would have worked nicely, but this is fine. Yes, if 2 data points don't fall on the line, you just make up 2 points. Even if 2 data points did fall on the line, if you didn't want to use them, you could still just get 2 points from the line. As long as you're picking 2 points from the line, data points or not, either way. Now, we really did the tricky part. I think the tricky part is figuring out how to draw the line and then figuring out 2 points that are on the line. Once you do that, it's pretty easy. So I need to find M and I need to find B. How am I going to find M?
55 minus 40 over 12 minus 6.
Very good. All right, when I subtract, I'm getting 15 over 6, which reduces to 5 halves. Great. That's my M. Now I need to find B. How am I going to find B? Plug it in. Good. Use one of the data points. I'll just use the first one that we found. So that's my X, that's my Y. So 40 equals 5 halves times 6 plus B. All right, when I solve for B, I'm coming up with 25. Anyone agree?
Yeah.
I'll just write it in my M and B spot. So this is what I need to write my equation. I'm going to write the equation under the graph. I'm kind of out of space. So I'm getting Y equals 5 halves X plus 25. Again, do not stay awake all of your Friday night trying to draw perfect best fit lines, okay? It doesn't actually have to be the best fit, just a good fit's fine. Don't stress. Get something close to what the book says or what your neighbor has. Don't stress too much. Okay? Any questions? Here is your homework. It is not too long because these do take a little bit of time and it's all odds, so check them in the back of the book.